All right, let's talk about something you probably never think about. The invisible code that, well, basically runs our entire world. I'm talking about the programming that moves your paycheck, that approves your loans, and keeps all the world's money flowing. Today, we're going to pull back that curtain and look at the AI that's being built to rewrite it all from the ground up.
So let's just start with a number. Get this, 95%. Think about that. 95% of every single ATM swipe on this planet relies on this one piece of hidden technology, a kind of digital ghost from a totally different era of computing.
So, what is this thing? What is this invisible engine that's quietly powering everything from our credit card swipes to massive stock trades, all without us even knowing its name?
Well, the answer is a programming language called COBOL, which comes from the age of giant mainframe computers. And the scale here, it's just mind-boggling. We are not talking about some dusty, forgotten relic. Over $3 trillion in commerce flows through COBOL systems every single day. It's the literal bedrock of global finance.
But here's the problem, right? A bedrock that was laid down more than half a century ago is starting to show some really serious cracks. And this is leading us to a huge, looming crisis that people in the know are calling the COBOL Cliff.
To really get a feel for the day-to-day pain this causes, just look at how banks spend their tech money. See that huge slice of the pie? A wild 75% of their entire IT budget is spent just on maintenance, just keeping the lights on for these ancient systems. That leaves this tiny little sliver for building anything new.
And this cliff is really a double whammy. First, you've got the talent void. The folks who actually built and understand these systems, well, they're retiring, and they're taking decades of essential knowledge right out the door with them. And second, there's this extreme inflexibility. These systems are monolithic, which means everything is just one giant, tangled block of code. This is why it can take a bank over 18 months just to launch a simple new feature on their mobile app. 18 months!
So how in the world do you fix a foundation that's crumbling without bringing the whole building crashing down? Well, you bring in a specialist crew. And in this case, it's not a team of people, but a specialized AI that's designed to be both a demolition expert and a master rebuilding crew for some of the highest stakes code on the planet.
Now, this is super important to understand. This isn't just a simple translation. The old way of doing this was called transpilation, and it was kind of like using an online tool to translate a beautiful, complex poem. You get all the words back, sure, but they're jumbled, they lose all the rhythm, all the meaning. This new AI uses something called semantic refactoring. It's more like having a literary expert who deeply understands the intent of the original poem and then masterfully rewrites it in a modern language. It creates something that's clean, efficient, and that people can actually understand. It's like swapping a giant, unchangeable statue for a set of high-tech Lego bricks. Now you can upgrade a single brick without having to rebuild the entire thing.
So how does this AI crew actually work? Well, it operates as a team of 3 distinct agents. First up, you have the archaeologist. It dives into millions of lines of that old, tangled code to map out exactly what it's all supposed to be doing, all the business logic. Then the architect takes that map and designs a brand new modern system using those Lego-like microservices. And finally, the builder and tester agents get to work writing the clean new code, and this is the most important part, proving that it works absolutely flawlessly.
And that phrase right there, prove it works flawlessly, that's everything. I mean, when you're talking about systems that handle trillions of dollars, almost perfect is an absolute catastrophe. So this brings us to the most critical part of this whole thing, the functional equivalence test.
So what is functional equivalence? It's a mathematical proof. It is an ironclad guarantee that the new, modern code produces the exact same financial result as the old code. We're talking down to the very last penny. There can be zero, and I mean zero, deviation.
And you get that proof with something called the golden master test. The AI runs the new code right alongside the old code, and it feeds both systems hundreds of thousands of different inputs and historical transactions. The whole goal is to prove with mathematical certainty that the outputs match perfectly, every single time.
And really, this gets to the human side of all this amazing technology. It isn't just about code, it's about confidence. This level of proof is what replaces fear with verifiable trust. It's what lets a chief information officer at a major bank actually sleep at night while the very core of their system is being rewritten from scratch.
Okay, so we've seen the problem, and we've seen this incredibly sophisticated solution. Now, let's talk about the money, because fixing this isn't just a technical challenge, it is a massive economic opportunity. We're talking about the $300 billion rewrite.
The market for updating these old applications is just colossal. The total addressable market you're seeing there is $300 billion. I mean, to put that in perspective, that's bigger than the entire global video game industry. And the more focused market they're starting with, the big institutions that are already looking for a solution, is still a huge $45 billion. This is not a niche problem.
But you can't just walk into a major bank and say, hey, let us replace your entire core system. It would never work. You need a really clever strategy. And the approach here is brilliant. It's a three-phase plan. Phase 1 is the Trojan horse, a low-cost audit tool that scans their system and gives them valuable risk reports. That gets a foot in the door. Then they use what's called the Strangler fig pattern, which is just a fantastic name. They replace one tiny, non-critical piece at a time. This builds trust by proving the tech works on a small scale. And finally, once that trust is there, they can scale up and become a mass migration factory, the go-to engine for modernizing the entire Fortune 500.
You know, when you step back, this whole COBOL story is really just one example of a hidden, aging foundation. It really makes you wonder, what other invisible legacy systems is our modern world built on, just quietly ticking away, waiting for their own COBOL Cliff?